God's sake. All right. Go ahead. All right, ladies and gentlemen, good morning. Welcome to Elementary Physics course, Summer Edition. There are certain requirements for this course. One of those requirements is having a WebAssign account. So if you have not done it yet, please take a syllabus and follow the instructions. And that's important to do it today. Меня зовут Валентин Викторович Ворошилов. Я закончил Пермский государственный университет по специальности теоретическая физика. What you're feeling right now has a name, the language barrier. There might be many barriers between what I say and what you understand. So I'm going to try to do my best to lower those barriers, and you have to do your part. For example, when you're really, really confused about something, what do? Can't hear you. Меня зовут Валентин Викторович Ворошилов. Я закончил Пермский государственный университет по специальности теоретическая физика, а также Московский академический институт по специальности педагогика. Я могу говорить и говорить. Я могу продолжать в том же духе, пока кто-нибудь в конце концов. Да, yes? Oh, sorry. My name is Dr. Valentin Voroshilov. I know it's also a complicated name, so I shrunk it to a very simple, short nickname. This is how all my students call me usually, but if you don't like this nickname, you have options to choose from. By the way, I'm gonna keep talking, but turns out this is the last day version of this lecture. I added a slide, and I like that slide. You know, I worked on it, so I want to use that copy of the lecture. Supposedly it's already here on my OneDrive, and I do not advertise OneDrive. Any cloud drive is as good as, you know. It just Boston University prefers OneDrive. Let's see. Yes. These are the options. Approved. By whom? By me. So, this is how I will be signing my emails to you, Mr. V. It's easier. And you can, well, that's the only person on the campus right now who has that nickname, Mr. V. So if I hear it, I know you're calling me. So I have an opening right now for a student who would be helping me around. If anybody is interested, please talk to me after this class or tomorrow. You can think about it. It's a very simple task, just helping with moving stuff in and out. I got my education in Russia, and I moved here afterwards. I worked in Russia as an educator in different capacities, and then I moved here. And I don't have my formal education in English. I had to learn it after I moved. And my pronunciation and grammar sometimes may be way off, which is your problem, not mine, of course. And the way I sound has nothing to do to what's happening in my mind, because when I start thinking about what I'm saying and I forget to control how I say it, I might start speaking too loud, too quiet, too fast, too slow. You have to just ignore it and just try to focus on the content. And you can find all professional information about me online if you want to. This is just a copy from one of past evaluations. Don't read it, it's too many. The point is, for every positive opinion, there is exactly opposite, a negative one. And for every negative opinion, there is exactly opposite, a positive one. And nothing gonna change that. It's always a distribution in the end, from I hate it to I loved it. So these two I like the most. You can tell he wants his student to understand and do well, and never felt like he cared for his students. And that, of course, begs the question, how could it happen? Two students, two people, spend the same time in the same room, watching and listening, same person, in the end came up with completely opposite views, right? So, that's actually my question to you. How could it happen? I'm going to ask you questions every lecture, many times. Be prepared. Well, I've got 6 weeks ahead. I've got plenty of time. Any ideas? Just venture an idea. You know what to do, right? You have to raise your hand. So that attracts my attention, and I say, yes, please.
People experience things differently.
Well, that answers any questions about humans. But in general, that's the right direction. Choosing your teacher, instructor, is like choosing your friends. We cannot choose parents, but we can choose friends, we can choose a spouse, and if we made our choice and really hate it in the war, later on, we don't have to stick to that choice. We always have a right to a divorce. So even I don't want anybody to leave this course, officially I have to inform you that you have that option. It's your choice, not mine. I cannot leave. I have to come every day and do it. But you can, although that would make me very sad. Some people think that there are many universes. If that's true, there might be a copy of you taking a copy of this course from a copy of me. If that happens, those guys are liars. Here in this room, in this universe, everybody gets the best grade, no matter what other copy of me would say. And thinking positive is very important, especially when you take physics course or calculus or chemistry, any intense course, because if from the beginning you think, no, it's going to be too hard, why even bother? Think positive and you will succeed. All right, so that's the last reminder about having a WebAssign account, because today I'm going to start asking you questions. And if you haven't done it yet, you should do this. And by the way, just to get a feeling, how many people don't have the WebAssign account yet? Please raise your hand. Well, the person who emailed me said he or she had an account, but something wrong with the username. So you have an account. Your username is just maybe off. That usually is fixable. So, I mean, don't have an account, cannot log in. Anybody? Perfect. I think it's first time in 10 years everybody has an account on the first day. So, in that case, this is a question. So how does it work? You should log in into WebAssign. For that, you should use any device. And because you will be doing this every lecture, it's kind of advisable to have it prepared, ready to go before a lecture begins, because you're going to do it anyway. I like WebAssign because it's robust, it's reliable. It usually works on any platform. You don't have to use a computer, a phone, a tablet, anything should do it. And it collects all important information. I can see who answered, what, when, and even from where based on IP address. It doesn't matter for this question. This is an anonymous question. I just want to see a distribution, see if it's usual or not, because if it's a usual distribution, it's a usual class, I don't have to make any adjustments. If something is really weird starts happening, I may need to do some adjustments. So, I can see in real time what's happening. I can see some people didn't log in. Why? For example, number one, Michael Amir, are you here? This person. Michael Amir? No? Okay, that solves the puzzle. All right, so, and now I want to see a distribution, so I'll look at this summary. Question 1 was about timing. Well, this is question 2, complicated, and I want to see sometimes people answer a question which hasn't been even asked for yet, Why? I didn't ask question 3 yet. I didn't. And now I know, technically, who did that. And answering a question that wasn't asked, technically, is a violation of a code. It's kind of cheating. So you'd rather not doing that in the future. All right? There's a person who goes way ahead. That person already don't understand questions, even if those questions weren't asked yet. Well, at this point, you didn't know how WebAssign works, but now you do. All right? So, complicated. Yes, that's the most common answer usually, although it is a wrong answer. People choose different, most common answers from the past, and I want to address all of them in red. That's important. First of all, it is never fun. Learning physics or mathematics or chemistry, it is not fun. Learning in general is work, work, and work. It might sometimes be, kind of in a certain way fun work with a fun element in it. But in general, learning always requires work and effort. Boring, some people say. That depends. Is reading boring? Some people don't like reading because it's boring for them. Some not. Cooking, for some it's a very emotional event, and for some cooking is very boring. So that's relative. And complicated, no. That's a myth, one of many myths about physics, and a common myth. You only can succeed in physics if you are good at mathematics. That's wrong. No. That's a myth. I will prove that. And this is also a myth because people sometimes confuse the meaning of complicated and hard, simple and easy. For example, if you have an old mechanical watch, you want to put a screw in it. It's a very simple task. It doesn't require any brain power. You have a watch, you have a screwdriver, and you put it in. But it's not an easy task because your fingers are large, screw is tiny, keeps falling out, your hands are shaking, your vision is not good. So simple and easy, not the same thing, and hard and complicated, not the same thing. Complicated means it's difficult to comprehend, but physics has a very straightforward logic. All we need to know is that logic. That's what lecture's for. And then how to apply that logic to, well, specific situations. Everything which has logic is simple. And there's another common term about physics or math or chemistry, hard. Again, this is like boring. It's relative. Something what is hard for one person may be easy for another, like climbing a wall. Is it hard? Driving, swimming. And we always have to keep in perspective there are things much harder. For example, we will learn how to solve a problem about walking on a rope, but it's much harder to actually learn how to walk on a rope than to solve that problem. And not everybody can manage many, many objects at the same time. But every, well, at least healthy person can manage a couple. One, two. That doesn't require training. It's a natural ability. When we learn physics, we also have to manipulate with objects. But those objects are in our mind, mental objects, mental entities. And of course, not everybody can get a Nobel Prize, but everyone can manipulate with 1, 2, 3 mental objects at the same time. So it's, achievable for everybody. Everyone who is in this room can get an A, in theory at least, because everyone passed SATs at some point, and everyone who knows multiplication table can solve a quadratic equation, right-angle triangle, is ready. At least for this course, it's elementary. Yeah, it's an elementary physics course. And physics has strategy. We don't have to memorize many things. We need to learn the strategy and apply it every time. And for every problem, every person uses exactly the same strategy. No matter it's you, me, Einstein, the strategy is always the same. Several steps we have to follow through, done. Although normally we do not write strategy as a sequence of steps. We write it as a list of questions we need to answer. This is a copy from a syllabus. You can have that page with you always. And anytime when you get stuck, you can refer to this page and start answering those questions, and they will lead you to the answer. It's much important to learn how to design, create, develop a solution than to memorize a solution. Because we cannot memorize solutions for several hundred problems, but we can learn one strategy for solving all problems. The easiest science is mathematics. It doesn't require imagination. Set of rules, follow those rules. Physics is the second easiest. It is based on imagination. One of the reasons is physics based on experiments, and we have no time, no equipment to do all the experiments, so we must be able to imagine those experiments and then apply some mathematics to it. And your mathematical skills, well, have been tested if you've done it already. Tomorrow I'm going to post the answers. You can compare your answers with the right answers, and then you can go to office hours and clarify everything which wasn't clear. That's it. And when we learn, we make mistakes. It's natural. So if you made a mistake, try again. Try something new. And it's always helpful to talk to someone, share your thoughts, and form groups, use Piazza. Physics is somewhere here. Yeah. Learning physics is based on fundamental abilities like imagination, but there are other subjects or areas based on physics, and nowadays you can find physics in economics, in medicine, in sport, anywhere. That's why more and more people take in physics. However, not all teachers know how to teach physics properly. Sometimes they teach it as just a accumulation, a combination of disconnected facts. And that's not what science is. This is more like a religion. Yeah, religion, it's a set of rules. Do this. Why? I said so. That's it. Science is based on, well, logical judgment. This is a copy from a syllabus. If you are a pre-med student, please read it later. It basically says that learning physics and becoming a doctor have many similarities. Question: how do you feel about this statement? I feel like I'm very good at physics. If you agree, if you think yes, you are very good, number 9 is your answer. If you completely disagree, if you think, no, you're very, very bad at it, you can choose one, and of course anything in between. This is, again, an anonymous question. I'm not going to look at who answered what, just a distribution. So be honest. Well, be honest with you, at least. And again, I remember distributions in the past. I hope this one will be similar. So again, I wouldn't have to make many adjustments. So you should start choosing your answer. And I'm gonna, where is it? Here. I'm gonna refresh my page and check the distribution. And I would expect, so that's the question number 3. Yeah, I would expect that middle answers usually have more answers. And that's what I see right here. It's a safe choice. Yeah. But it's a good choice. That's what most people do. But I have to tell you up front, whatever you feel about it has nothing to do to your final grade. Feelings usually not related to our performance, and more often they impede our actions, they help. So it's very important to learn how to manage our feelings, especially on the exam. So what is important? Well, if it's not feelings, something else. learning is like building a pyramid. We have to have a foundation, and that foundation includes a little bit of algebra, a little bit of geometry, ability to memorize some things, time management skills. That's what we call a background. Of course, depending on your history, maybe you're out of school many years ago, you may forgot something. It means only one thing. You may need to set aside a little bit of time to recover missing background and move ahead. That's it. In theory, again, everyone can get an A. The finish line is the same for everybody. Depending on the background, the starting point might be a little bit different. Boston University is at the top of the list of the universities in the world. That's why Boston University faculty have certain expectations to Boston University students. And number one and number two are these. Students should be active and organized. If we put it together, proactive. Proactive means planning ahead. And you have all the information needed to plan your actions ahead. That's, again, from a syllabus. And physics is an intense course, but not because it's physics, because it's summer. The same amount of material people learn in the spring or in the fall, the same amount of work people do in the spring or in the fall, but they do it in 16 weeks. And now, the same amount of material, work and effort is squeezed in 6 weeks. That's why basically you should do physics every day, a little bit. And that's why I technically do not recommend mixing physics with other intense courses like chemistry. People have done it and succeeded, but sometimes they didn't get the grade they wanted to when they tried to take physics, chemistry, and something else. So that's just an advice. This is a standard course, not a fancy flipped classroom or studio-based course. It has standard structure, lectures, homework, labs, discussions. The only difference is in the summer, in this course, labs and discussions are put together in one longer investigative laboratory unit. So it's longer, but on the other hand, you don't have to drive twice for discussions and labs, so plus and minuses. And a year after a year, a survey after a survey, business owners, employers, they say that they value specific skills less than they value general. They call it soft skills now, like ability to communicate, think critically. And those are actually skills required to succeed in any intense course, not just physics. So any intense course, like physics, chemistry, calculus, automatically is a stepping stone to a professional career. Every university has two missions. As a scientific institution, the mission is advancing science, but as an educational institution, its mission is advancing people. And that's what employers care about. But in order to fulfill this mission, every university has to function in a very specific way. Every university functions as a filter. It's filtering people in and out based on the ability to absorb skills and the knowledge required for future profession. It's not something administration or faculty wants. It's just a built-in feature of every university, starting from the first university established about 1,100 years ago. And that's nothing new. Nothing new in the history of mankind. People have known for thousands of years what skills people need in order to propel the progress. That's what we do here in this university and every university, propelling progress. Well, come back to this particular course. Because it's a standard course, the mission of a lecture is demonstrating, presenting certain information, demonstrating how that information can be applied. And usually, about 20% of you may feel it's way too easy. 20% of you may feel it's challenging, but that's what office hours are for. And no matter where you are, you should participate in lectures. And participation means solving problems with me. I'm going to be solving, asking questions, answering questions I'm asking to you. Because every thought you think, every word you say, every move you make, every sketch you draw, make you better learn. Because we humans, when we act, any action excites extra neurons in our brain that helps to build connections. And that's what learning essentially is, building connections in the brain. And even mouse can do that. So, participate. And labs. Officially, they begin today, but you know now already that the lab number 1 is not actual lab, it's just a survey. You have a whole day to do it. You don't have to go to your lab room during your lab time today. It's not a requirement today. You can do it anywhere, anytime, until 10 p.m. All you need is a computer and the access to the internet and the WebAssign account. That's it. The actual lab begins tomorrow, and as I said, they have a special name in this course, investigative laboratories, because you will have to investigate, especially tomorrow. Tomorrow, you're going to feel like every scientist does, frustrated. You will be discovering some things. First, you're going to take some data, and then you will have to analyze those data to extract some patterns, some information. And only then I will cover that material in the lecture to make it as clear as possible. It's not going to be, every time, but the first lab is going to be like that. However, you will have a teaching fellow who will be helping you. In this course, a teaching fellow cannot just watch what you're doing. That's forbidden for them. And they know that. They have to work as a tutor. If you ever had a tutor, that's what a teaching fellow is. Of course, tutoring one person and tutoring many persons, slightly different situation. But anyway, their goal is helping you to get complete understanding of what you're doing by the end of this lab. If you have any confusion, you have to call them, ask a question, and they will do that. Now, if you leave this room through these doors, on the right, you will see room 121. That's our resource room. All office hours will take place in that room. On the left, there is a message board, and you can find the lab schedule there. And lab exercises might take place in different rooms. In different rooms, could have been 128, 130, 134. There are lab rooms in the basement, so you have to pay attention to the schedule. I will usually tell you on the first slide the room for this week. But if you missed it, you can go to the message board, check the schedule. And actually, every door also has a lab schedule. You can just see PY105, room such and such, and go to that room. Almost all labs based on the use of computer interface. And sometimes you can see a pop-up window, like update this, update that. Ignore them. Just close them. Please don't do anything. And don't use those computers for anything but lab related. Now I'm going to tell you a secret. I know why you're here. Well, there is structure, a hierarchy of reasons, but the top reason is because you want to succeed in your life. I believe you do. And in order to succeed in your life, you have only two options. Number one, you have to be a genius. Number two, you have to be liked. And no one likes people who leave a mess behind for other people to take care of it. So the rule is very simple. That's a standard rule of work ethic. Keep your workplace clean. That's it. After you finish your lab exercise, make sure before you're leaving, everything is clean, and then you can go ahead. Question. Now, this is an example of a question when first you have to read all the answers, then choose the answer, remember the number, and then choose that number on a WebAssign. Because WebAssign will not give you a copy of possible answers usually. It's on the screen. So you read, you choose, then you go to the WebAssign and just click the number of your choice. This is a short memory test. Let's see. Well, what was number 3? 6 people. No, 3 is wrong. Lab may take place in any room in this building, technically, so just keep it in mind. That's why I had a slide with the description of several standard room locations. Again, 128, 130, 134, B19, B15. It is not always in 134. All right, homework. All homework assignments will be delivered electronically. If you have no WebAssign account, you cannot do homework. In order to graduate, you have to have at least a half done. In already 11 years of teaching this course, 3 students didn't pass the course because they didn't do all the homework. Probably they just paid tuition to spend summer in Boston, I don't know. Now, this year, I want to try an experiment. I have never done it before. I have no idea how it might affect you, your grade. It's on you. You have to make a choice. So, because this is a standard on-site course, technically you are required to attend every lecture. Boston University policy offers you 5 lectures you can miss because, I don't know, you're not feeling well, your car broke, or something else might happen, family emergencies. But there is a camera in this room. Every lecture is being taped, unless something fails technically. If something fails, I have a backup. I have my phone capturing. The quality is not as good as the BU quality, but if that fails, better something than nothing. All slides will be posted on Blackboard, also will be available to you. And I don't know how to check it yet, but this lecture also should be streaming live right now. And technically, everyone who is signed up for this course should be able to watch it right now, live. I was promised that. So maybe you already have an email. Probably you should have an automatic email when streaming starts, so you could go and check. So that's how I imagine it should work. And that is why I give you an option, a choice. You can sign a waiver, so that will be a second document you sign. So this is mandatory from everybody. A waiver is on you. You can think about it, and if you sign a waiver, you basically promise that you will watch all the lectures sometimes. I cannot know if you don't do that. Yeah, it's on you. But if you sign a waiver, I will not require attendance from you. I will not require signing in. And if you sign a waiver, you still can, of course, attend every lecture. Again, it's an option which you should consider. Do you want to use that option or not? It's an experiment, basically. Every homework has 4 parts, because we have exam 1, exam 2, exam 3. We have homework 1, homework 2, homework 3, but each homework has 4 parts in it, and each part has several problems. In the past, different parts had different deadlines, but I always had a student who would send me an email, please move the deadline. So now, all parts have exactly the same deadline a day before the exam. For some of you, it might actually be a bad thing, kind of a trap. You may want to wait until the last day and try to solve all homework problems at once. I can tell you with the absolute certainty you will fail. People tried, people failed. It's impossible. So again, you should do homework problems a little bit of every day. These are kind of recommended deadlines, timeline. Now, when you do a WebAssign homework, for each part of each problem, you have 6 trials, because everybody makes mistakes. But if you tried it 4 times and still didn't get it, stop trying, go to office hours. Don't lose submissions. Plus, WebAssign accepts your answer if that answer is within 4% from a correct answer. In order to be that accurate, usually it's sufficient to keep 4 digits after decimal point. You can keep more. I don't require using significant figures or error analysis. It's not important. But also using more digits might not help. This is an example when a student just lost 2 submissions because this answer was wrong. That's a clear sign this number is at least 4% away from the right answer. 4% of 300 is 10. Yeah. So this number is 10 units away from the right answer, and it's really, really unlikely it's right on the boundary. So adding decimal points to a very wrong number doesn't make it any better. Well, this table is already filled with names. It's on a message board. So these are office hours. You can go. I have my office hours. I have office hours today, later in the day. So every day of a week, there are office hours. Use them. In the end, of course, everybody gets a grade. This is how it's going to be calculated. Lectures, labs, homework, 3 exams together, and you get the final grade. A final grade is a number between 0 and 100. We have no negative grades. There is no extra credit. No one ever gets 0, but people did get 100 sometimes. But still, that's not the last thing you want to. There has to be a transition made from a numerical grade to a letter grade. How do we do that? We split this segment into smaller segments. How do we do that? We draw a boundary. As soon as there's a boundary, there's always a student close to that boundary. That's inevitable. There's a strategy to be above the boundary, and the strategy is simple. Do your best. This is an example from one of the past grades. So here in red, a copy of the scale provided by, that's a generic scale provided by the syllabus following BU policy. And you can see that year, the actual boundaries were exactly the same. However, that is not always the case. Sometimes I have to move a boundary. This is an example when a boundary was moved from 95 to 96. It's not because I wanted to. The boundary is a feature which must obey a specific rule. It has to be stable. It has to be robust. Because when we're calculating, there is no absolutely accurate number ever. There's always rounding issues. So a boundary must be drawn between grades which have a large gap. So if you see here, grade, the gaps is 0.1, 0.1, 0.02, very small gap. And then you can see 0.47, a half of a point, it's a very large gap. Hard to bridge. That's why this is where a boundary has to be drawn. So it's an algorithmic procedure. A computer, a robot can do that. It doesn't require thinking, feeling, just a calculator. Now a student writes, would you please round my grade because I won't have a better grade? No, I wouldn't. Why would I? First of all, again, I have to follow, and I always do, policies. Why would I break policies? And I want to risk my position. Breaking policies is always a risk. If you drive on a red light, it's on you. It's a risk. So you take it or not. I don't. And BU policy says grading has to be fair. What does it mean? Same for everybody. If I would round numbers for one person, I would have to do it for everybody, and that would make all boundaries disappear. That's impossible. Another student. Is there anything at all I can do to earn extra? No. That's how grade is calculated. There are 6 elements: lectures, labs, homework, exam. There's nothing else. Extra credit doesn't exist. Wherever you get in the end, you get in the end. A student writes, I feel, well, first of all, in physics, that's a wrong way to start a letter. We cannot rely on feelings. We have to rely on data. And I put a clear effort. Well, if I would be able to talk to that student, I would ask, do you think you're the only one who put a clear effort? Do you think others didn't? But even if that would be a case, still, there is no term says effort. It doesn't exist. Maybe it should have been, I don't know. But again, it's not up to me. It's about policy. This is where the grading ends. So, taking a course is in a way like running a marathon. Every single digit matters in the end to rank. The grades and the grading procedure is purely automatic. The best strategy for not losing any points is not losing any points. Lectures, labs, homework, if you do your part, automatically give you 37%. And what's more important, if you really put your effort in lectures, labs, and homework, you are automatically ready for the exams, because exams, well, they composed of problems. The number depends. Usually it's something between 8 and 10. 8 longer, 10 shorter. You know. But all problems and parts of those problems are similar to some problem or some part of some problem you have seen already if you are participating in the lecture, doing your homework, and doing your lab. Not just sitting with your partner, but actually doing the lab. And the most important skill is recognition, being able to recognize in a problem you need to solve here and now, a problem you have solved before, and just apply the same strategy you applied before. And again, in order to train that ability, that's trainable, that's a skill, not genetic. I advise keep this page with you, and if you're stuck, refer to this page, try to follow this strategy. Any questions anytime? You can raise your hand and ask a question. And if you raise a hand and ask a question, maybe I will answer. Depending on your question, depending on the place in the lecture, I may give a full answer, give some pointers, or ask you to see me or someone else after the lecture. That depends. Eventually, every question will be answered. Sometimes immediately, sometimes later. Yeah. So, as I said, there might be some barriers between understanding, well, even when people born in the same country and use the same language, they still may misunderstand each other. So there are different levels of understanding. Of course, starting from words and sentences. Sentences are important. Those sentences give instructions what to do. But there is only so much can be done during a lecture. There is something you have to do after. That's on you. That's why I like this saying. Can you guess what saying is that? If you look at the horse and water. Anyone? One can. Yes. Yes. You can bring a horse to water, but you can't make it drink. So in this metaphor, you're a horse, young, strong, beautiful horse, and I'm water. It's up to you. Do you want a drink? Physics is science. Teaching physics is not. That's why people who are good at science may not be good at teaching, and vice versa. And let's talk a little bit about what is science. It's very important. Science is the most important invention of humanity, at least from my point of view. It's a human practice. Every practice has a specific mission. What do you think is the mission of science? Yes? Absolutely right. See, it's easy. You raise your hand, you say right words. Good. Understanding the world, that's what a mission of science. Understanding the world where? Everywhere. Outside of us, inside of us. But there are many specific sciences and actually many specific missions. You cannot read it, of course, but you can download it afterwards if you're curious and read after the lecture that slide. What do you think is the mission of a specific science? How do we know that our understanding is actually correct? What do we do to test that? Yes? Which show what? Exactly. And there is one single word for that. Starts from P, prediction. That's what the mission. We need to know if our understanding is correct. To test it, we make a prediction. If it's correct, that means our view of the world is correct. And in order to make prediction, we look for patterns around us. A human brain, an animal brain, a brain in general, is most powerful pattern recognition machine in the universe. And patterns are everywhere. And there are different types of patterns. Visual, numerical, sound patterns, actually. Does it work? What do I want to do? No. All right. What do I make? And again. When we see a pattern, we want to describe it. It's always about objects, certain objects, and something, what is happening to those objects. We call it a process. Those objects, processes, they have properties, and we need to be able to say something about those properties to fellow scientists. And this is how we do that. Hey, Jim. Hey, Jim, do you see that thing? No, Jim, not that thing. That thing with the thing which is doing that thing. Do you get it? No? That's why we don't do it this way. That's why every science has invented a specific language, and every language has a dictionary. And how do we learn language? By memorizing. So, this is the physics language. This is copies from the syllabus. This is what we have to memorize, have to learn. That's a language which we need to understand and we need to be able to use. And first of all, Even this is less than required from cat. But if it looks like a lot, and you are a pre-med student, keep in mind you're going to learn, you're going to memorize 100 times more than this. You will have to memorize the name of every bone, or muscle, or disease, or chemical. So this is just a preparation for you. So that's why, again, if you think about becoming a doctor, you should read this slide, this page. So the most advanced science always eventually use some data, numbers, because when we use data, when we use numbers, we can extract information about correlations, we can derive some equations, we call them laws, and then we can use those equations to make more reliable predictions. That's why the most advanced sciences always involve some mathematics. That's inevitable. But that's why teaching physics is not science. There is not much data, reliable data, in science of education. It's more like art. And, well, basically it depends on the experience of a teacher. I am a very experienced teacher. You are lucky. Or not, if you don't like me. If you don't like my style. If my style doesn't match your style, you know. It's a very well-known fact from psychology. Every person has a certain learning style. Every teacher has a certain teaching style. Sometimes they may not match. If it's a bad match, no matter what's happening, it's not going to really work. Psychology. So, to get from words, from verbal description of what we see, to numbers, to numerical description, we need a certain procedure to make that transition. That procedure has a general name, measurement. And in physics, we have a specific type of measurement developed to make a transition toward numbers. In physics, a measurement requires, first, a choice of a standard. First, we need to agree on what we want to measure, and then on how. If we want to measure how heavy is this, first we name it, we call it, we want to measure mass. Then we have to agree on how would we measure. And a standard procedure is we have to choose the standard and call it 1, and then we have to compare all other objects which have the same property with the standard. Originally, the standard of mass actually looks something like this. A cylinder. And if we want to compare a mass of another object, compare. Yeah? That's what we do. Well, no, not enough. Well, now it feels the same. So if this is 1, that means it also is 1. But unfortunately, of course, we cannot rely on our feelings, so we have to use more accurate devices. Well, one of the first balances, basically same approach, but much easier now using a calibrated device. What do? We take the etalon. Well, first we write 0, then we write 1. Why? Because we set it to 1. And then we can divide between 1 and 0 in smaller parts. Or we can add 1 more, and because we know 1 and 1 more is 2, we can write 2 etc., etc. And now we have a graduated device which can measure mass, but we used a special standard for that. So we need an indication which standard was used. That indication has a name, a unit, and that's what we write after a number. 1, well, people chose to call the unit of mass a kilogram. So 1 kilogram, 1.5 kilograms, 2 kilograms. And of course, there are units for smaller and larger parts. We can use tons, milligrams. We just need to know how to relate those different units. Next important physical quantity is length. People gathered in France in 1961 and decided, let's call this 1 meter. And then they made more meters spread around the world. And now we have a copy of the etalon. Well, later it's been changed to a more accurate one, but still, this is 1 meter. If I want to measure length, what do I have to do? I have to count how many times I can fit 1 meter in the length of an object I want to measure. 1, 2, 3, 3 meters. And of course, I can also divide it into smaller parts. 1/10 decimeter, 1/100th centimeter, 1,000th millimeter. And we can use feet, yards, miles, kilometers. And again, we just need to know how to relate them. Next, the most important unit is unit of time. To define that unit, first we need a periodic process. Anything periodic, a year. Something that repeats itself, but a year is very long. This is much simpler. We can count it 1, 2, 3, Mississippi, 4, Mississippi. We can call it 1 something, and people call it 1 second. And then we can measure time using calibrated measuring devices. Yeah. We have plenty of those. All right. So those units, a kilogram, a meter, a second, those units are part of so-called international system of units. That's what people usually use nowadays in every physics course. But we don't have to stick to those units always. It's up to us. And if you need to measure something else, speed, acceleration, force, energy, we always can represent a combination of standards in terms of basic fundamental standards, mass, length, and time. And if we need to relate different types of units, we can use an equation, or people call it a factor. And if you don't know, if you have a problem to solve at home and you don't know how to relate, let's say, a meter and a feet, you can always just search for that. That's it. Let's do an example very quickly together. You should try it, and I should do it with you. This is a standard situation like you're driving and you read on your speedometer 54 miles per hour. What does it really mean? It means if you wait 1 hour, you will travel 54 miles. But we can ask a question, how many meters would you travel in 1 second? That would require making a transition from miles per hour into meters per second. In the end, we will get a new number with this new unit. And our goal is to calculate this number. This number. So I'm going to wait maybe a minute or two. Please try to calculate this number on your own. So this is the first actual problem you need to solve. It's a very straightforward, simple problem, but again, no matter what problem we need to solve, the strategy is always the same. There are some elements here, a number, a symbol, MI. We need to know what it represents. Yeah. A symbol, H. We need to know what that symbol represents. If we don't know those things, that's it, we're stuck. But if we're stuck, we go and do the search. We have to unstuck ourselves. We know from mathematics that if we multiply by 1, we do not change the value of expression. There is always invisible 1 in every expression. For example, this is 1 mile. This is 1 hour. It's helpful to see that number 1 because all conversion factors have a number 1 in it. And now we need to make a transition from 1 mile to 1 meter or several meters. So what does our brain do? Search. I see a mile. Is it a meter? No. Okay, doesn't work. That's no mile. I see a meter. Doesn't work. 1 hour, seconds. Actually, that works for a different thing. That's going to be done here. I can replace 1 hour with 3,600 seconds. Why can I make this replacement? Because of this sign in mathematics. If we replace one entity with another entity equivalent to first one, we do not change the value. So it's a standard action. Substitution. We have to keep both parts, a number and a letter which represents the unit. Keep going. Grams and kilograms doesn't work. Millimeters and a meter doesn't work. Mile. Oh, we got it. We found it. Now we can use it. How? Well, again, we have to replace 1 mile with an equivalent value in meters. And of course, we didn't even touch this number 54. We cannot leave an empty space. We just have to keep everything we don't touch. What do we do now? Well, if we see numbers, now we have to take a calculator and calculate it. And everybody needs a calculator. A standard calculator which has sine, cosine, trigonometry functions will do. So, what do we have to multiply or divide? Only numbers. You cannot enter letters in a calculator, right? So what do we do? 54 times 6, well, I prefer cancel everything I can before, at least 2 zeros. So 54 times 16 divided by 36. I could have reduced fraction 16 over 4, 36. So I get 24. Am I done? No. There's another part of this expression which cannot just disappear. So I have to keep it. And I keep it. And that's it. A simple example, the full strategy. Any questions? What's missing in that statement above? No units. How do we fix it? Well, again, we can do the search. Turns out that's millimeters. Millimeters is not a very intuitive unit, so we can convert it into something more intuitive. Feet, yards, meters, in anything we want to. And if we do that, of course, we get always different numbers, but those different numbers with different units are related to exactly the same length. Sometimes it doesn't matter what specific unit we want to use, we just need to know its length. That's why we have invented a special name for all units we can use for the same physical quantity. We call it a dimension. So millimeters, feet, miles, they all form one dimension, the dimension of length. Kilograms, tons, grams form the dimension of mass. And of course, seconds, years, etc., the dimension of time. And sometimes we just use a letter that indicates the dimension of the variable. It's important because in physics, there's a very strong rule we have to follow every time. For every equation in physics, the dimension on the left-hand side should be equal to the dimension of the right-hand side. That's it. Meters, meters, seconds, seconds, kilograms, kilograms. We cannot say 5 kilograms equals 5 seconds. That doesn't make any sense. So this is how we can check at least if an expression is wrong. If the dimension on the left is not the same as the dimension of the right, that can't be right, period. Well, this also helps to derive a unit of a complicated physical variable. We'll learn in the future. This is an expression for kinetic energy. It's mass, speed squared divided by a number. We know for the mass we can use kilograms. For speed we can use like miles per hour or meters per second. So what is the unit, or we can say dimension, of kinetic energy? Well, let's do it. You can do it because you have a notebook, and I can do it because I have a touch screen. Well, we can do it both ways. And actually, I prefer using specific units. It just makes more sense. What unit do we use for mass in International System of Units? Kilograms. And for speed, meters per second. So technically, we should say a dimension. These brackets represent the word dimension of a kinetic energy should be equal to, well, again, technically, we should write at least once the whole thing. The dimension of mass times dimension of speed squared divided by dimension of 2. Numbers have no units. Number 2, it's just a number. It doesn't have a unit. A dimension of nothing is 1. Dimensionless. Kilogram for mass, meter per second for speed. Don't forget to square it. And we can treat all variables as algebraical letters. So a kilogram, a meter squared, a second squared. Done. If I would like to rewrite this in general symbols, well, a dimension of mass is represented by a capital M letter. A dimension of a meter is represented by a capital L letter. The dimension of a second is represented by a capital T letter. Symbolical thinking comes from algebra. We don't really need to know algebra because it's so important. Calculations are rather simple, but we need to use algebraical thinking. We have to be able to manage to manipulate with variables. And I want to point at a very common situation right now. You see this M. It's a symbol for a meter. This M, what does it represent? Mass. The alphabet only has 26 letters, well, plus Greek alphabet. But still, in physics, we have many more physical variables than letters. That is why very often we have to use the same letter for different things. And we need to keep in mind the specific meaning of the letter. If we confuse meters and masses, that's not going to make any sense. That's mass, measured in kilograms. That's meters. All right, that's the first actual question to you. So you got to do your work. Then you have to look at the answers. You have to choose your answer. And you have to go to the website and choose a number which represents your answer. This expression, x equals 1 over 2 vt squared, came from them. I don't know. We don't know if it's a correct expression. We don't know if it's a wrong expression. We have to check the dimension on the left, the dimension on the right, and make a conclusion. Yes, following this equation is possible. That would have been if dimensions the same, or no, it's wrong. That would have been if dimensions are different. Now, x represents some distance. V represents some speed. T represents some time. So for dimension of length, you can use a general letter L or meters. For dimension of speed, you can use what we just used 2 minutes ago, L over T or meters per second. It's up to you. Do you want to use general dimensions or specific units? For dimension of time, you can use seconds. If you use international system of units. And then you have to do some algebra. And then you have to choose your answer, enter it in a web sign. And I'm going to check once in a while how many answers have been entered already. So this is for you to remember. I'm refreshing the page. It should be refreshed by now. This is the, oops, forgot, question number 5. Number 5 is here. We already have 41. Okay, I'm going to wait a little bit longer. We've got about 70 students for now. After some people sign a waiver, we may have much less audience. All right. again, if I have a choice between things which easier and even more easy, I use that even more easy, which means I don't use general dimensions. I use specific units, a meter, a question mark. A coefficient has no unit, meter over a second squared. I do a substitution for actual physical variable. Yeah. I use a letter that represents a unit I have to use to measure that variable. Now I can do some algebra. Every time when I see some variables which are related by some mathematical symbols like multiplication, division, subtraction, addition, I ask myself the same question. Can I make it simpler? Why? I don't remember. I don't care. Can I make it simpler? Yes. If it's a yes, do it. So I can cancel some things, at least here. And what I get left, mass on the left hand, mass times seconds on the right hand. Is this identical to this? Oh, meters, you see? I just made exactly the same mistake I warned you to not do. I could say I did it on purpose. And sometimes I do, but not usually on the first lecture. So it actually doesn't matter. It could be anything. The question is this identical to that? No. No. That's the answer. No. Next question. That's going to be the last question for today, I believe, because we still have like 2 minutes. I want to finish with this question, and I want to give you a hint. Oops. That means I have left only 1 minute. A liter is a measure of what? Is it a measure of length? Well, you should give me a chance. Is it a measure of area? Is it a measure of volume? Yes. Do you see any unit of volume here? No. So what is the answer? None of the above. Sometimes we don't even have to calculate things if we pay attention to the meaning of those units. All right, thank you very much. So we are done for today, and you still have to do some signing. So please, if you haven't done it yet, take a syllabus.
I have a question for the waiver. It's not going to be, like, the waiver says it's not going to affect our 7% attendance.
The waiver says that if I have it from you, I will not be taking your attendance. You will be automatically assumed attending, no matter if you're here or not.
I still have a question about how to transfer listening.
Well, I cannot help you now, but probably, so first of all, there will be a different class soon in this room. So we have to leave. I have to take care of this. And if you have time, you can wait for me in our resource room. And in about maximum 10 minutes, I can join you, and we can.
What's the what's the room number?
121.
Okay, thank
You go through these doors on the right.
you. Okay. If we don't go to class, do we still have to take the web assigned questions, like the lecture questions, on real time, or can we answer it during the day, like any time during the day?
The web assigned questions will be available only during the lecture. If you have any waiver signed, technically you don't have to participate. It is on you. You still can watch this lecture later because it's captured and it will be posted. And you can answer these questions for you. You pause, you try to do your best, and then you resume and you see if your answer is correct. But I cannot control that. Yes.
So I'm a student with disabilities, and I am trying to get you my paperwork. I didn't realize I had to fill out online forms now.
You can give me it later.
Whole new system. But you're gonna get a nice form about how I have a fluctuating attendance policy. I'll just sign this, and you can just hit no and just ignore it because
It doesn't matter.
works.
Yeah, I can do whatever you
that
want me
works.
to do.
This literally is just as effective.
Oh, okay.
That works very well.
Okay.
So thank you.
Sure.
Hi.
Yes.
How does the optional waiver account for the 7% participation?
In full.
So it just takes care of that?
Yes.
Okay.
You